Hello, my name is Knut Menden. I'm an architect and passive house designer. I'm going to talk to you about New South Wales' first prefabricated cross-laminated timber passive house building, which our studio, Menden Knut Architecture, built recently in Balgola. In this presentation, I will first cover a virtual house tour of the finished project, then show you more detail about the cross-laminated timber construction, and then add all of the additional details which turn this house into a passive house. We start with the site. The project is located in Balgola, northern suburbs of Sydney. As you can see, there's an existing house in the front, which is the 1920s Californian bungalow, and the addition has been installed in the backyard. The form was very much determined by the need to retain the existing gum trees. You can see it's quite densely populated with trees. It is obviously been a bit of a challenge to fit the extension in there. The crane during installation was standing on the road, reaching over the existing house and then lowering all of the elements into the backyard. Again, this is the overview of the site with the existing house at the front and the extension at the back. The extension is about 110 square meters. On the ground floor, we've got the new main entry to the building with this little link which connects the old and the new part. You've got the stair going upstairs, kitchen area, dining and living, and external terraces. On the upper level, we have the study and a bathroom, a walk-in wardrobe, and the master bedroom. This is a view of the exterior of the house. It's clad in local black butt timber, which is going to grey over time. It's been left untreated. Very fine batten detailing. You can see the triple glazed timber windows, and in the background you can see the existing house. The landscaping at the time of the photos hadn't been finished, but should be near completion now as well. This is more of a detail of the facade, a view from the garden into the kitchen and dining area. A more detailed look at the kitchen. All of the internal walls, floor and ceilings have been left in the exposed CLT, and additional elements have mainly been used in white. This is a view you've got when you enter the house through the little link. You look into a hopefully soon more greened little courtyard, and you can see on the right side the new house. You can see the stairs going to the upper level, and you can see into the kitchen, living, dining area. It's a little storeroom under the stair, and a view into the kitchen and dining area. On the wall you can also see the Alunos ventilation system, and in the background you can see the connection to the existing house. The living room will have a terrace, or has a terrace now at the back, and a more landscaped garden. As you can see at the top there, all of those lights have been included in the original cross-laminated timber prefabricated production, and it's the electrical conduits and lighting just had to be fitted in. And an overview of the whole ground floor. And in the background you see the existing house and connection to the house. Going up that stair, the stair has been prefabricated in cross-laminated timber as well, with just an additional timber tread finish on top of it to protect the edges of the spruce timber from the CLT. Balustrade is part of the same system as well. Now going up into the study area, you've got this long window which is used as a window seat as well, and a view from that area to the master bedroom. Currently the client is using the study as a master bedroom, and the master bedroom as the kids' bedroom, while the front of the house is still getting renovated. A view through the connection between the two rooms. The right side we've got the door to the bathroom, and this is a view into the bathroom. So the bathroom is essentially the only place which has not exposed timber walls in the entire building. And this is a view into the master bedroom, now kids' room. You can see again, deep window reveals to be used as window seats, and the same materiality over the room. And a view of how the window seats are getting used. Now I'm going to explain you a bit more about the cross-laminated timber construction. That was the method for this project. So everybody knows about timber framing as sort of a traditional residential construction, and everybody knows about concrete tilt-up prefabricated systems, which are sometimes used in commercial arrangements. And cross-laminated timber really is sort of a combination of the two systems. So cross-laminated timber consists of timber boards which are glued together at 90-degree angles and then form a solid slab. And this slab can be used in all different types. It can be pre-cut, windows can be added. We've got smaller elements, long elements, and they are then installed on site. This is a view of the crane lifting one of those 11-meter long panels over the existing house into the backyard. So why did we use cross-laminated timber for this project? So there are a whole lot of reasons to use that. Part of it is the quality of the finished product. It's prefabricated to a high standard in a controlled environment, and particularly in combination with passive house, this is of a large importance for the airtightness of the building, in my view. So you can use the CLT as an airtight wall or slab or roof, and then the only things that need to be done, instead of adding an additional membrane to achieve the airtightness, you can use the joint, you can tape the joints to achieve this. So why did we use cross-laminated timber for this project? There are quite a few. Obviously, the quality of the finished product is prefabricated to the highest standards in a controlled environment, which in combination with passive house is very important if you think about airtightness. All of the walls, the CLT walls and slabs are airtight within themselves, so you only need to tape the joints to achieve the full airtightness here. There's a speed of construction on site and associated cost reduction. There's less on-site labor. Obviously, health and psychological benefits of timber. Generally, thinking about biophilic design, the sustainability of the construction, both for energy efficiency, taking advantage of the timber's thermal properties, and the reduction of CO2 emissions. It's essentially the only renewable building product, timber. And obviously, there's also the aesthetic and visual beauty of the structure itself. If you look at the global warming potential of mass timber structures and compare that to more traditional structures, maybe not in the residential environment, but generally in construction environment, you compare it to concrete, a concrete structure of the same size, same type, would have 60 to 80% more primary energy used than an equivalent mass timber structure. And then coming to the argument about transport, because the CLT that we've used here is coming from Austria. Transporting something 12,000 kilometers overseas on a ship in a container is the equivalent in CO2 emissions to transporting something above land with a truck. That just puts it into perspective overall. This is now a time lapse of the installation of the Bargola passive house. You can see the installation of the floor panels put in place. There's a crane standing behind us, reaching over the existing house. You can just sort of see some tiles at the bottom left corner. So you can see it's pretty close to the boundary on the left side, and the neighbor was rather difficult, so it was really important to not pass over his airspace. And on the right side, you can just see the edge of those large gum trees. So very restricted site, but went incredibly smooth. You've just seen the large 11-meter panel being installed, and essentially the part that took the longest was the area around the stairs. So the stairs were prefabricated. Within the slabs, we also had the prefabrication for the conduits. The lighting cutouts were already included, and Now you can see the next level getting up. The whole structure was installed in 15 hours, but spread over 2 days because of council regulations and the time that it takes to set up the mobile crane and pack it all away again. Overall, after 8 days, the entire structure was complete with the insulated and waterproof membrane installed and ready to essentially go into the interior and start the external cladding after 2 weeks. Just some stats about the CO2 in this project. So generally, this project has stored 55 tons of carbon dioxide in the mass timber structure. Compare that to a traditional build, which would have emitted 20 tons of CO2. And that's an equivalent of 16 cars taken off the road for a whole year. And just another fact is essentially the entire timber structure is regrown in just 15 seconds. Now I'm going to go into the next part, which is talking more about the passive house components. Bargola Residence is New South Wales' first cross-laminated timber certified passive house. This is a cross-section of the project. I'm just running through the 5 key parts of the construction. Continuous thermal insulation across the entire building. We've used a wood fiber insulation with a lambda value of 0.038. We've used Schneider and Gutex as the insulation for the roof and for the walls, and we've used an XPS for the underside of the suspended slab. U value for the walls is 0.25. For the roof, we've got 0.18, and for the slab, we've got 0.35. The air tightness of the entire house was achieved by using the CLT components, that is for the walls, for the floor, and for the roof, and only taping the joints with a Tescon Extora tape to achieve the air tightness. The initial air tightness test achieved a 0.33 air exchange per hour. The windows, for the windows we've used Döpfner timber frame windows and triple glazing from Saint-Gobain. U value of the frame is 1.02 watts per square meter Kelvin, and the glass is 0.72 watts per square meter Kelvin. As an external shading device, we've used external aluminium Venetians, retractable and adjustable. Obviously, thermal bridge-free design or optimization has been used for the project. And the heat recovery ventilation used here was a decentralized system. We've used the Lunas Next and Lunas E2 modules, which I will go into more detail later. This is a view of the CLT structure when it was sort of just finished. You can see the slabs and the wall panels, and you can see the joints in between. And you can see how the taping has just been started at the corner, the black tape you can see there, which is closing off the joints. And this is the same view with the insulation added and the waterproof membrane and the vertical timber battens to start the timber cladding finish. This was after, the right photo is after the 2 weeks. The only thing that didn't arrive in time, unfortunately, were the windows. So in the meantime, they've been replaced by this plastic sheeting and added in later. This is a view of the back wall. You can see very well how the buildup is. So you've got the CLT with the joints taped. The builder actually went a bit further and also taped all of the screw fixing. So usually the connection between the walls and slab is done by about 30 centimeter long screws. And wherever there was a screw, there was a bit of tape added as well. You can see the wood fiber insulation at the bottom getting installed. And on the right side, you see a cross section of the wall buildup. We've got the CLT insulation air cavity. Then we added a 4mm FC sheet to protect the membrane from UV because we used an open batten system. So just making sure that the membrane is not affected by this. This is a view of the roof. The Menden 3000 was used as the roof sheeting, and this one has just the battens installed with the color bond clip lock roofing getting installed afterwards. Again, this was, I think, on day 3 of the installation. More of a detail, like a typical detail for a CLT construction, and how you get the air tightness with the tape across the joints. Air tightness testing, as I mentioned, was done initially and achieved an air tightness of 0.33. The final air tightness test achieved an air tightness of 0.4. The reason we found out why that was a bit less than originally was actually the door connecting the existing and new building, which we adjusted later. So I assume now it's probably back closer to the 0.33 rather than the 0.4. Some more details of taping and of how we've run the electrical conduits. So the electrical conduits were installed between the CLT and the insulation, and obviously all of the penetrations taped and airtight. The windows we used were Döpfner timber windows, triple glazed. You can see how they've been installed here. You can also see the installation of the external shading device. And if you look at the cross section, obviously, ideally, the window would have been pushed out a bit further. And the main reason why it's sitting in this location is because of the external shading, which was integrated within the external cladding. The thermal bridge analysis, though, showed that this was all still working. A view of the external shading devices. They're electrically operated external aluminium venetions. Obviously, you can direct them in any direction you want, so you can have the view outside, or you can sort of block out the light completely from the inside. And this is an image of how you can see how it's installed within the wall cavity behind the timber cladding. Coming to the ventilation concept, as I mentioned, we've got a decentralized system here. On the ground floor, we've used a Lunos Next with the air in and out through that heat exchanger. So one of those Lunos Next system is taking care of the entire ground floor. And on the upper floor, we've got another Lunos Next, which is installed within the walk-in wardrobe, and it extracts the air out of the bathroom via ducting and pushes it into the bedroom via ducting as well. There's another one which is taking part of the more open part of the house, the Lunos E2. They work as a pair, so there's one diagonally across the room there, and they work in tandem, and they change direction in certain intervals. On this level, we also have the cooling installed, so that's installed near the open stairway so that the air actually gets circulated across the entire house in that location. This is during construction. You can see the Lunos Next on the ground floor, which sits there at the wall. There's the same unit on the upper level, just with the ducts. You can see a little cross section of how this works with the heat exchanger being integrated within the wall thickness. So it's a very efficient system in terms of the space that it takes up. And on the upper level, you can see in the background the Lunos E2, which is one of the two installed on the upper level. And again, the heat exchanger is installed within the thickness of the external wall. And yeah, this is sort of it. You can see here, I guess, probably the most important footnote on a building, in my view. And please feel free to ask any questions. More than happy to try to answer everything that you would like to know about this project. And thank you for listening.